Hi, in this video we're going to talk about reducing functions. So what are reducing functions? Well, reducing functions are functions that recombine an iterable recursively, ending up with a single returned value. They're also called accumulators, aggregators, or sometimes even folding functions. I'm just going to keep referring to them as reducing functions. But let's look at an example that will make it quite clear as to what this means and what's going on. For example, we want to find the maximum value in an iterable. That's a reducing function. It's taking a sequence or an iterable in more general terms, and from that, it's giving us a single value back based on all the elements in that sequence. So essentially, it's a mapping, right, from an iterable to a value. And it's a mapping that happens in a very specific way. So let's take a look at an example. How might we find the maximum in a sequence? So our sequence, let's say we have n values from a0 to an minus 1. So here I'm indexing, which is why I'm calling this a sequence, not just an iterable. There's a, there's a notion of order in this, so we can take elements out. We can talk about the first element, the second element, and so on. Next, let's define a small function that is going to take two parameters, a and b, and it's going to return the maximum value of those two arguments. So that's all it does, just returns the max of two values. Now let's do this. Let's say that we want to find the maximum of our iterable. So we want to end up with a result that's going to be the maximum of all the values in this sequence here. We start by setting result equal to the first element, right? That's usually how you're going to find a max in a list. You're going to say, okay, well, make the maximum equal to the first element. That might be correct. And then what do? You look at every element thereafter and you check, is it bigger? If it is, well, okay, that's the biggest element. And you keep going until you've exhausted the list. So we're going to do that exactly here. We're going to say result is the maximum of that result, that current one, which is a0, with a1. And whichever one's bigger, we're going to put that into the result and say, well, that's the maximum now. And we're going to keep doing that for every element in the sequence. So after we've done that and exhausted all the elements of the sequence, we've essentially found the maximum value in that sequence. So you can see what's happening is that we're just applying this max value recursively or iteratively, right? We're doing it multiple times, and I'm saying recursive because what's result here? Well, it's the previous one, but what's result here? It's the max, right? So this is the max of result a comma 1 with a comma 2. So you can think of this as a recursion. But think of it in terms of loops. That's probably going to be simpler for now. So this allows us to find the maximum value in that sequence. Now we haven't studied iterables in general, so I'm going to stick to sequences in all the examples I do. But as we'll see later on, this will actually work with any iterable, not just sequences. So using a loop, let's actually write this out in code using a loop. So we'll start with a list, right? This is a list. We're going to define this function called maxValue, and it's basically just a small lambda function, and it's going to take two arguments. So again, this is critical. It's always two arguments. And what is it going to return? Well, it's going to return a if a is greater than b, otherwise it's going to return b. So basically, it's going to return the maximum of those two values. Next, let's look at this code. Let's define this function, maxSequence. It takes in a parameter called sequence, which will pass, L as an argument when we call this function. And what does it do? It says result is sequence 0, right? So in other words, result equals 5. That's the first element. Now we're going to loop through every element in sequence, and for every element in sequence, starting at 1, right? We're not going to redo the first one. There's no need. We've already handled it. It's now in our result. So we always start at the second element. And we're going to set the result equal to the maximum value of our previous result with e. So in this case, we're going to set the result to the maximum of 5, which is our current result, and 8. So 8 being the second element here, right? Or the first element in this loop. But we start the loop at the second element, so we're at 8. So the result is 8. We do that again. So now we say result is the max of 8 and 6, which is the next value in our sequence. So the result is still 8. We do that again. and we take max of 8 with the next value in the sequence, which is 10. So now we get a value of 10 for our maximum, for our result. And we do that again, and we take the max of 10 and 9. Well, the max of 10 and 9 is still 10, so result is 10. And that's it, we're done with the loop. And now we return the result, which is 10, which happens to be the maximum value in the sequence. So notice the sequence of steps. We initialized our result to 5. Next, we said our result was equal to the maximum of 5 and 8, the next element in the sequence. That gave us some value, 8. That's now our new result. We now apply this again, and we say take the max of the current result and 6. Well, the max of the current result is 8. 6, max is still 8. So now our current result, our new current result is 8. We again rinse and repeat. Max of 8, that 8 here that we obtained in the previous step, with 10. So now the max is 10, the result is 10. And we apply it once more, max of 10 and 9. And that result is 10, and that's what we return because we're done, we've exhausted the list or the iterable. So the result is 10, and that is the maximum of that list. So it's pretty straightforward if you think of it in terms of that loop that we wrote in that code. So we could do the same thing for other things. Let's say we want to find the minimum. Well, the only thing that we need to do to find the minimum, instead of using a function that returns the maximum of 2 values, we're going to use a function that returns the minimum of 2 values. So every time we're going to find something that's smaller potentially. So how would we do it? Well, this is the same code as before. The only difference is that I've renamed this function here, and the function that I'm applying inside the loop is the min value function. It's this function here. It's not that max value. That's the only difference. Everything else stayed the same. So we could do this instead, right? You're starting to see a pattern that everything stays the same. The only thing that changes is min value. So let's write a reduce function that's a little bit more general. And we're going to need to know what this function is. So we're going to need to pass it as a parameter, as an argument to this function. So the parameter fn will take the function, and then the sequence will be what it was before. What is the sequence that we want to apply this to? And then our code will be identical, result equals sequence 0 for x in sequence 1, result equals, and now this is the key difference, we're going to take fn and apply that, right? So we're not going to hard code the function that we're using, we're just going to pass that in as an argument. And then once we're done, we return the result. So if we call underscore reduce with this lambda, a greater than b else b, what does this lambda do? It returns the maximum, right, of a and b. So this will give us the maximum of the list. And if we use the other lambda that we saw before, if a is less than b else b, that's calculating the minimum of 2 values, we'll end up with the minimum of the list. What about adding all the elements? We can also reduce by adding all the elements in a sequence or in an iterable in general. Well, we just need to define a lambda, a function that basically adds its 2 arguments. So let's do that, and let's apply it to L. And let's run this code, and let's see if we run through this code, what's happening, right? So this code is the same as that reduce function that we just wrote. I haven't changed that at all. The only thing I've changed is that we're going to pass the add function, right, for the function in this underscore reduce function. So if we call underscore reduce add comma L, what happens? Well, let's step through it. The result is going to be sequence 0. So the result is going to be 5. Next, we're in the loop now, and we're going to add, the function is add, right? That's what we passed in. We're going to add result with 8. So we're going to add 5 and 8, and that's going to be our new result. That's going to be 13. Rinse and repeat. We now move on to 6, and we're going to add the previous result, 13, with 6. That's 19. You see how we're creating this cumulative sum? We do that one more time. We have 19, the previous result, and 10, we get 29. And for the last element, and the last, therefore, iteration in this loop, we're going to take 29 and add it to 9. And so we end up with 38. That's our result. That's what gets returned. And that is the sum of all the elements in this list. So this reduce is a really important kind of concept. It's an important function. And Python actually, has it for us. We don't have to write it ourselves. I created this underscore reduce to help you understand how it works. But Python has it, and it doesn't have the restriction of only you being, able to specify sequence types. You can use any kind of iterable. We had to stick to a sequence because we were using indexing and slicing, right? We had sequence 0, that was an index, and then we had, 4x in sequence 1 colon, that was a slice. You can only do that with sequence types, and you can't do that, let's say, with a set. That won't work. However, Python's reduce function will work with sets as well. And we'll see that in the code when we switch to that. So we would have to import it from the functools module. That's where it resides, in the functools module. So let's do this again with our example. Now here I'm using a list, which is a sequence type, but again, we don't have to use a sequence type. And now I'm calling Python's reduce. And you'll notice that's why I called my reduce function underscore reduce, just so I'm not stepping over the toes of this reduce function. Otherwise, I might be shadowing it. If I do a from functools import reduce, and then later on I do a def reduce, well, guess what? Whenever you call reduce, it's going to call your definition, your implementation of reduce, not Python's. So it's generally a good idea not to use Python's methods for your method names, for your function names, and also go ahead and just put an underscore in front. That works just as easily, or call it something else, whatever. But the underscore is fairly common. So if we call reduce just as before, we're calling it with this lambda here that's going to return the maximum of A and B, and we apply that to L, then it's going to give us the maximum, which is going to be 10. Similarly, if we use a lambda that's returning the minimum of A and B, then when we do that, it's going to return the minimum, just as before, except we're using Python's built-in reduce. Again, we can also use an addition for the lambda function, and it's just going to return, therefore, the sum of everything in that list. So reduce works on any iterable, as I mentioned. I may just show you that now if we have a set, this wouldn't work with the underscore reduce. That will fail because this is a set and you can't find, the 0 element of a set. There is no such concept. But in Python's reduce, that will work just fine. So if we do this, we're again looking for the minimum, and it will work and return the minimum of that set, which is 2. Now we can also apply it to other things, like for example, a string. A string is a sequence type. It's a sequence of characters. So our underscore reduce function would actually work in this case. And all we're doing here is we're finding the minimum. Well, what does it mean when we talk about the minimum of characters? Well, we're talking about lexicographical ordering. So if you think of the ASCII table, for example, that's lexicographically ordered characters, and it will actually work out the same thing here, or the same way. So the smallest character in here is going to be H. That's going to have the lowest character code, if you want to think of it that way. So when we apply reduce to that, we are going to get H back, because that is the smallest element. We can also do something like this. This is kind of a little different, and it's still a reducing function. But what is it doing? Let's take a look. Our lambda here is saying A plus a space plus B. So we're doing string concatenation here, and that's why I'm passing in strings. So here I'm passing a tuple, which again is an iterable. And so the first element is Python. So Python, and then what are we going to do? Well, that's going to be our result. Our result is going to be Python. Plus a space plus the next element. So plus is. So we're going to get Python space is. Then we apply again, we're going to get Python space is space awesome. And so we end up with Python is awesome. Now there's actually a better way of doing this. The string, when we get to the string library and the string data type later on in this course, we'll see, but there's a join method in string objects that we can use instead. But I just wanted to show you that you can get something that you may not have expected also by using a reduce, right? Here we've just concatenated strings together. Okay, so let's look at some of the built-in reducing functions, because Python has a few built-in functions, a few built-in reducing functions. It's got a lot of built-in functions, but a few reducing functions. Join is one that I just mentioned, but we have some other ones as well, like min. It's so common to try and find the minimum value in an iterable. That's built in. You don't even have to import it. It's just right built into the standard library. And so we get this. Min of this list will return the minimum. So we don't have to do reduce and then the lambda. None of that. It's just built in. Same thing with max. Max is built in. That will return the maximum inside that iterable. Sum is also defined. It's so common to try and add up all the elements of an iterable that that's built in as well. So if we call sum of some iterable, in this case this list, we'll get the sum of all the elements in that iterable. In this case 38. Now we have two more, and these are related to Boolean expressions. So we have any and all. So let's look at any first. And any is defined this way. You call it by saying any and then your iterable, and it will return true if any element in L is truthy. It will return false otherwise. And all is called by all with whatever iterable, and it will return true if every element in L is truthy and false otherwise. So what's happening with any and all is that it's looking at the truth value of each element in your iterable. And in the any case, it will return true if any of them are truthy. So basically it's doing an OR between the truth values of every element in your iterable and returning that result. The all, on the other hand, is putting an AND between all the values. So if every element in L is truthy, so if the truth value of element 1 and the truth value of element 2 and the truth value of element 3 and so on is true, that's what gets returned, true. So that's a reduction as well. Let's see how we might actually implement it ourselves using the reduce function. So let's say we start with a sequence. 0, empty string, none, and 100. 0 has a truth value of false, it's falsy. The empty string is also falsy, none is falsy, and 100 is truthy. So if we were to look at our result and make that equal to the truth value of 0 or the truth value of the empty string and so on, well, we'd get true or we'd get false or false or false or true. The whole thing will be true, right? So our result will be true. Now note that I'm not doing 0 or empty string or none or 100, because if you remember what we did when we looked at the Boolean operators, that's not going to return a Boolean value. That's actually going to return one of the elements in the ORs. And in this case, it's going to return 100 because that's the first truthy value, right? So be careful with that. That's not what we want. We actually want to return a true or false. We don't want to return the element in this case. So we're going to cast everything to a bool. We're going to basically look at the truth value first and then do the ORs. So you'll see, what are we doing repeatedly? We're taking two values, we're looking at the truth value of both values, and we're ORing them. And we're doing that repeatedly. Well, that's a reduction. We're reducing. So we do this, right? We'd say result equals bool of 0. That would be false. Next, we say result equals result or bool of the empty string. Well, bool of empty string is false, so we have false or false. That's still false. Then we have result equals our previous result, which was false, or bool of none. Well, again, bool none is false, so we have false or false. That's false. And then the last element, when we handle that, we have result equals result or bool of 100. Bool of 100 is true. 100 is truthy. So we have now false or true, so the net effect is that result is now equal to true. And so that's what we return. So we can do this now by just using reduce, right? We see this pattern here and we know what it means, right? Even this pattern here, by now you should start realizing we can use a reduce for this. So what are we going to pass in for the function? Well, we're going to pass this. Our lambda is going to take two parameters, a and b, and it's going to look at the truth value of a or the truth value of b. And then we'll apply it, in this case, to the list L. And when we do that, we get true as well. So this is the same thing as any. Any is just an implementation for us, so we don't have to go through this. But that's how you would implement it yourself. And you can do the same thing with all as well, of course. So let's look at another example, which is finding all the product, or finding the product of all the elements in an iterable. That's not built into Python. The sum is, but not the product. Sometimes you may want to do that. So let's see how we might do that. So it's very similar to adding, right? The difference is that, let's say for this list here, we just want to find the multiplication, right? Instead of doing a sum, instead of doing an addition, we want to find the product of all the elements in this list. So as you might think, all we need to do is just change our lambda. Our lambda is the product, right? A times B. And then we apply that to the sequence L. So what's our result? Our result starts with 1. That gets initialized to the first element of the sequence. Next, we go into a loop that basically will iterate through the remaining elements of the iterable. And we're going to multiply it with the previous result. So the next result is going to be the previous result times 3, which is 3. The next result is going to be the previous result times 5. Well, previous result was 3, so 3 times 5 is 15. And once more, our next result is going to be the previous result times 6, the last element in the sequence. So we have 15 times 6, which is 90. And so we end up with the product of 1, 3, 5, and 6. So that's how you might find the product of elements in an iterable. So of course this has actually an application. We can calculate n factorial using that. Let's take a look at what n factorial is. Just to refresh your memory, it's 1 times 2 times 3 all the way up to n, right? So we're multiplying the sequence of numbers 1, 2, 3 up to n, right? So if, for example, 5 factorial would be 1 times 2 times 3 times 4 times 5. So if we look at this range function, and if we look at the range starting at 1 and ending but not including 6, that will generate basically an iterable containing 1, 2, 3, 4, 5, right? It's going to generate the sequence of numbers, 1, 2, 3, 4, and 5. If we can then multiply all these numbers together, we've just calculated 5 factorial. In general, if we do range from 1 to n plus 1, we'll end up with a sequence of numbers from 1 up to n. So to calculate n factorial, we just find the product of all the elements in the range. Well, that's straightforward. We have a reduce function, so we call reduce. The function we use is going to be this a times b, which is multiplying, and we pass in the range. So for 5 factorial, we'd pass in 6, range of 1 through 6, and that will actually calculate 5 factorial. We didn't have to write the recursive function in this case. We used reduce, which has kind of all that built in for us already. Okay, so the last thing that I want to mention is that the reduce function actually has an initializer. And in the code, I'll show you how we might implement something like that ourselves, although I won't do a full implementation of it. But the reduce function has a third optional parameter that defaults to none, which is why we haven't talked about it so far. And you can think of it essentially as adding something to the front of the iterable. Remember in the code when we wrote our own reduce, we had an initializer, right? We were initializing the result to the first element of the sequence, or the first element of the iterable. What the initializer does in the reduce function in Python, it basically overrides that and say, no, don't use the first element, right, as your initial value for a result. Use this initializer value instead, and then do the same thing, but apply to all the elements of the iterable. So it's like adding a value basically ahead of the remaining iterables, ahead of the elements of the iterables, and then Python will use that as its start value as it starts doing its recursion. So it's often used to handle the case when your iterable is empty. Because what happens if we have this piece of code where L is an empty list, and then we call reduce, we want to add all the elements in L. Well, if we do that, then we're going to get an exception. We're going to get a runtime error. Python's going to basically bark at us and say, I can't do this because this is empty. So to avoid that problem, we pass it the initializer. And we tell it, hey, use an initializer of 1. In this case, I'm saying use an initializer of 1. Now we've got to be a little careful. In this case, what's going to happen? Well, the list is empty, so it's going to return 1 because that was the initial value of that result. So it's going to return 1. But now you have to be careful, because if it's not empty, then let's say our list is 1, 2, 3, and we give it an initializer of 1. Remember that we are essentially adding this, we're putting this in front of everything and saying that's the initial value. So the initial value is not this 1 over here, it's this 1 over here. So in fact, we're going to end up adding 1 plus 2 plus 3. And so we would get a result of 7. So just to make it clear, let's say that I specified the initializer to be 100. Then what we would have would be 100 as our initial value, plus everything else that's in the list. So in this case, we'll end up with 106. So be careful with the initializer, right? So to do a summation of a list, I would not use an initializer of 1 or 100. I would use an initializer of 0 because it won't affect the sum. If something is in there, 0 plus 1 plus 2 plus 3 will still be 6. If the list is empty, it will give me 0 back. In the case of a product, let's say I want to find the product of everything, I would use an initializer of 1 because 1 isn't going to modify the product of 1, 2, and 3. But if my list is empty, it will return a 1. That may not be what I want, in which case I'd have to put an if statement in front of that and test for it and so on. So be careful with the initializer. So with that said, let's jump into some code and see how all that works. Thanks for watching, and I'll see you in a bit.